This is the video for 1-9, and this video is a continuation because I am combining sections 8 and 9 into one lesson. So look at the first example I have here. It says, is 310 a solution of the equation y equals 4x? So this is an ordered pair. So what this question is asking is, when x is 3, is y 10? In other words, when your input is 3, is your output 10? And in these last two lessons, I'm using a lot of terminology like independent and dependent variable and function and input and output, and I'm assuming you were taught those concepts in pre-algebra, but if you're struggling to understand those words and what exactly they mean, then you need to go ahead and shoot me an email so we can go back and do a reteach. But again, it's saying when x is 3, is y 10? So what do you need to do? Well, you need to go ahead and plug in the values that are given for your variables, and I'm saying when x is 3, is y 10? And no, it's not. So the answer is no, 310 is not a solution for this equation. So go ahead and do the on your own, and you're trying to figure out if these ordered pairs are solutions to the equation y equals 4x. And label your ordered pairs x, y. Go ahead and do that so you don't lose track of what is your value for x and what's your value for y. Okay, so here are your answers. Yes, yes, no, yes. And if you got any of these wrong, then go ahead and hit pause on this video and look at my work and see what I did. Let's move on to the next example. It says using a table, an equation, and a graph. So it says both Carrie and her sister were born on October 25th, but Kim was born 2 years before Carrie. So represent the relationship between their ages using a table, an equation, and a graph. Okay. So let me think about this. Let me read back what it says about my situation here. It says Kim was born 2 years before Carrie. So that means Kim is older. So however old Carrie is, Kim is 2 years older than that. So here's your equation. In order for me to set it up on a graph, let me think of it this way. It's like saying y equals x plus 2 or x plus 2 equals y. We tend to think of equations in terms of x and y, and so if you need to replace that with an x and a y just so you know what's your dependent and what's your independent variable here on your graph, then go ahead and do so. So I'm calling Kim y, and I'm calling Carrie x. So let me go ahead and do my table. So Carrie, or C, is my input. This is my function, and that's my output. So when Carrie is 0, meaning when she was first born, Kim was 2. When Carrie was 1, Kim is 3. When Carrie was 2, Kim was 4. And here's your table, so you can start seeing your pattern. Every time Carrie goes up by 1, Kim goes up by 1. It's just my starting point was there at 0, 2. When Carrie was 0, Kim was 2. And then every time Carrie went up by 1 year, Kim went up by 1 year. And so there is a table, an equation, and a graph that describes this situation. So go ahead and try that on your own. Okay, let me work this out for you. Will runs 6 laps before Megan joins him at the track. Then they run together at the same pace. So represent the number of laps they both run using a table, a graph, and an equation. So again, let's look at this situation here. It says Will runs 6 laps before Megan joins him at the track. So it doesn't matter how far. Now remember, they're running together at the same pace. They're running together at the same pace. That's important. So it doesn't matter how many laps Megan has gone. Will have always gone 6 more than her. It doesn't matter how many laps Megan goes. Will is going to have gone 6 more than hers, because before Megan even steps foot on the track, Will has gone 6 laps. So there's my equation. Now let me go ahead. Let me write it in terms of x and y, just so you can see it better. And so here's my table. Okay, so Megan's going to be my input. Here's my function. And so Will is going to be my output. So when Megan has run 0 laps, Will has run 6. When Megan has run 1 lap, Will has run 7. When Megan ran 2 laps, Will has run 8. So again, you can see the pattern starting here. Every time Megan runs 1 lap, the amount of laps Will has run has gone up by 1 as well. So there's your table. And I'm calling Megan X, and I'm calling Will Y. So when Megan has run no laps, Will has run 6. And then after that, every time Megan runs 1 more, Will has run 1 more. Okay? And finally, we're going to start talking about extending a pattern. The table shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern. What is the total number of tiles in a figure with 8 blue tiles? All right, well first, let's go ahead and extend the pattern. So this is going up by 1. Every time the number of blue tiles in the shape goes up by 1, the total number of tiles in the shape goes up by 9. So to answer the question, what is the total number of tiles in a figure with 8 blue tiles? We're looking at 8 blue tiles. It will have 72. 72. But now write an expression to represent the write an expression to represent the number of total tiles for a shape with k blue tiles. So in other words, how am I getting from 8 to 72? How am I getting from 7 to 63? How am I getting from 6 to 54? I'm multiplying the number of blue tiles in the shape by 9. So if I have k, my total number of tiles in the shape is going to be 9k. So the expression, my total number of tiles, is going to equal 9 times the number of blue tiles. Okay, go ahead and pause the video and work out the on your own. Okay, so if a person has read 45 fiction books, how old are they? And then what is the equation that describes this relationship? Well, let's figure out the pattern. What's happening here? 10, 15, 20, 25, 30, 35, 40, 45. Let me just extend the pattern. Now what's happening here? 15, 20, 25, 30, 35, 40, 45, 50. Again, I'm just extending the pattern. So let's look at the question. It says, if a person has read 45 fiction books, how old are they? So if they've read 45 fiction books, they're 40 years old. And what is the equation that describes this relationship? How am I going from 10 to 15? What am I doing to get from 15 to 20? How do I go from 20 to 25? And it has to be the same. It has to be consistent. So whatever it is you say for this has to be the same for this and for this. So what am I doing? I'm adding 5. I'm taking the age of the person and I'm adding 5, and that's going to give me the total number of fiction books that they've read. And there's my formula. There's my equation that describes this relationship. The age of the person plus 5 equals the total number of fiction books they read. Okay, so go ahead and try your homework and email me if you have any questions.